do the 1 o'clock classes test here. So it says determine L6, L6. See, there are 6 spaces. 1, 2, 3, 4, 5, 6. And so the left side of the first one has a height of 3, but we need to multiply by the width, and the width of each one of these is 3. So we got 3 times the height of 3, and then the left side of the second one is a 6, and then a 10, and then a 15, and then a 16, which is 3 times 19, 20, and 30 is 50? Is that right? Oop, 3, 6, oh, I missed a 7, plus a 7, plus a 10, plus 15, plus 6. 1, 2, 3, 4, 5, 6 lefts. Okay, so that's 57. I thought the number was wrong, which is 150, 171. And since we're doing a heights of velocity, which is a height in meters per second, times a width of seconds, units cancel and we get meters for our units. If we do M3, we've got to break it into 3 groups. 1, 2, 3. 3 gaps. And each one is 6 wide. That's the width. And the height in the middle is 6 on the first one. Height in the middle of the second one is a 10. And the height in the middle of the last one is 16. So I've got 26, 32. 6 times 32. 6 times 30 is 180 plus 12, 192. Also meters, same reason. And what do these values represent? Well, that's the underneath the velocity curve, then we'd be finding the change, not the actual distance or displacement, it's the change in displacement. Now, since all the velocities are positive, this is also equal to the change in distance. If there was any negative, it would not be the change in distance, it would only be the change in displacement, because the negative area would be causing it to go backwards. And we'd lose the distance. Okay, that's 1. 2. 5x is what f of x is. And so if we're supposed to use this, we're going to have the limit as n goes to infinity. The width of the interval, delta x. See, if we're going from a to b, the width would be b minus a, and we're splitting it up n times, so divided by n. That's what delta x is. But I'm going to leave it just delta x for the moment. And then I've got the sum as I goes from 1 to n. And I've got to put a plus delta xi into f of x, and that's down here. So I got 5 times a plus delta x times I, which is going to be the limit as n goes to infinity. I'm going to leave this delta x here. I'm going to split this up, or I'm going to pull the 5 out because it's times all of this stuff, so I can factor out the 5. And I'm going to have the sum as I goes from 1 to n of a plus, and in this one I got the sum of this, and the delta x comes out, so delta x, and it's only on this part of it, so I can't take it all the way out here, I goes from 1 to n of I. So I split this sum up and I pulled the 5 out. And I pulled the delta x out of the second sum. So this becomes the limit as n approaches infinity of 5 delta x, 5 times whatever the change in x is, times, this says, when I is 1, we get an a. When I is 2, we get an a. And when I is 3, we get an a. In fact, when I is, for each number between 1 and n, we get an a. So we get n number of a's. Plus, we get the delta x. And this says add up the numbers from 1 to n. So that'd be 1 plus 2 plus 3 plus 4 up to n. And there's a formula for that. That's n squared over 2 plus n over 2. Okay. So this would become the limit as n approaches infinity. Haven't done the limit yet. I'm going to take this times this, and now I'm going to put in b minus a over n for the delta x. So I'm going to have 5 na, and delta x is going to be b minus a over n. So that's this times this. Plus, now I got a 5 delta x times delta x, so that's going to be 5 times delta x squared, so that would be, and delta x is b minus a over n, and that quantity is squared, so square the numerator and the denominator, times the first part of this, and I'm also going to have that same thing times the second part. Times the n over 2. Okay, so as these n's would cancel, so there's no n's in here, and as if I let n go to infinity, it doesn't change this, so I get 5a times this. So I get 5ab minus 5a squared, and then here the n squareds cancel, so I get plus 5 halves, and so as n goes to infinity, this doesn't change because there's no n's in it. B minus a squared is b squared minus 2ab plus b squared. I got the 2, I got the 5, and the n squareds cancel. Plus, on this one of the n's cancel, but that leaves an n in the denominator, and when n goes to infinity, this whole fraction will go to 0. So I have 5ab minus 5a squared plus 5 halves b squared. 5 halves times this would be just minus 5ab, and 5 halves times that is plus 5 halves b squared. So I got a positive 5 halves b squared. These two cancel, and I got a 2.5 b, a squared. That should have been an a. So I got 5.5 b squared and minus 5a squared plus 5 halves, or 2.5 a squared, leaves us minus 5 plus 2.5 is minus 2.5 minus 5 halves a squared, which is what I should get if I integrate from a to b of 5x dx. That becomes 5x squared over 2 evaluated from a to b. So I get 5 halves b squared minus 5 halves a squared. Exactly that. All right, the next one. It says, which is better, L6 or T6? Well, L6, if I'm going to divide from 0 to 3 into 6 parts, each one would be a half wide. So I'm going to split it in columns every half unit. And I'm going to use the height at the left side, so the left side height there. I'd be doing that one, then that one, then that one, that one, that one, and that one. So since it's a decreasing function, I've got some extra area there. Now, how does T6 work? Well, let's look at that. Let's see. On a T, I'm doing trapezoid. So I'd go from the left height to the right height with a straight segment and do the rectangle that way. Well, clearly that's closer to the correct area under the graph than that. It's an underestimate, but it's not as much as the over is on that one. And if I connect the left height to the right height on this one, again, it's slightly under, but not near as much under as that one's over. And this one, since it curves up and then curves down, it's pretty close estimate if I go from there. Some over, some under. So it's going to be really close to the correct amount. Here, the trapezoid is going to give me extra area, but not as much as the left. Here, I'm going to get pretty close to the correct area and pretty close to the correct area. So my answer for the first question, T6 is better because, and now you can explain it several ways. You can point to how much over the L6 is compared to the T6, or you can say that T6 follows the curve better and has less error on each section, or the trapezoids match the area better than rectangles. Whatever you want to do there, you got to go say that. Okay? So then you have to calculate the trapezoid. And some people did this way. T6 would be the width of the intervals. Well, each one of these is a half unit wide. And they did it the left height, which is 6.5 plus the right height, 6.2 divided by 2, and that's the correct height, times the width of a half, and that would be for the first one, plus 6.2 plus, about 5.5 divided by 2, plus 5.5 divided by 2, plus 3.5 divided by 2, nope, 5.5 plus 3.5 divided by 2, plus 3.5 plus 2.4 divided by 2, plus 2.4 plus 2 divided by 2, plus 2 plus 1.8 divided by 2. And you can work that out, but boy, that's a lot of work doing it that way. It's a lot easier if you realize that the T6, another way to describe this, L6 would be an overestimate, right 6 would be an underestimate, and T6 is an average of L6 and R6. L6 plus R6 divided by 2 is T6, and so that might be another reason why you'd say it's a better estimate. But anyway, And you could do L6 and R6, but that's still too more complicated than it needs to be. Clearly, we got half of 5.6. We got half and another half of 6.2. That's 6.5, I should say, on the first one. Then we got half of this one and half of this one. So I have half of the first height. I got 1/2 for the width. Half of the first height plus 6.2 over 2, and 6.2 over 2 is just 6.2. I get all the heights in between. Plus half of the last height. Which works out to be, I think, about, let's see, I've got that someplace here. 11.9, I think. 11.875, something like that. Okay. Page 2. So this says F is the inches at T hours after noon. So at 4 p.m., 4 hours after noon, the amount of snow is 6 inches at 4 p.m. At 2 p.m., there's 4 inches. That doesn't say there was 4 inches on the ground from noon to 4, because there could have been a little bit on the ground before noon, or none at noon to 1, and it all happened later. So all we know is there's 4 inches piled up at 2, and at 9, there's 18 inches at 9 p.m. Now this is a change. So the change in the amount of ground on the ground is 11 inches fell between 2 p.m. and 7 p.m. So these are changes. These are just what that is at that time. So this is a change from 4.5 inches fell between 1:30 and 4 p.m. This wants to know how much is there on the ground at 7 p.m. Not any change. Let's see. From 4 to 7. At 4 there were 6 inches. And let's see. At 2 there was 4 inches already. And then from 2 to 7 there was 11 inches. So we had 4 inches at 2 plus 11 more inches from 2 to 7, so there had to be 15 inches at 7 p.m. So I've got what it was and what it's doing. What the explanation of what it is, the units, and how much. The next one is a change. So I want to find out how much more snow fell between 4 and 7. Well, from 4, there was 6 inches. At 7, there's 15. So 6 to 15, that's 9 inches fell between, or piled up, between 4 p.m. and 7 p.m. That's a change. Or I could say 9 inches more between 4 p.m. and 7 p.m. The next one is just how much is on the ground at 1:30. And between 1:30 and 4, 4.5 inches fell. And by 4, there's 6 inches. So if the 6 inches minus the 4.5 inches that fell, we're back to 1.5 inches. And this is how much was on the not ground, but patio, I guess we're talking about here. 1.5 inches on the patio at 1:30. Now this last one. It says this is a change, and from 2 to 7 the change was 11 inches. 11 inches fell from 2 to 7, and the 7 minus 2 is the hours. So 7 minus 2 is 5 hours. So we have 11/5, or 2.2 if you want to change it to decimal, inches per hour is the average rate of snowfall between 2 p.m. and 7 p.m. All right, the next one. We have uneven function. So what it looks like on the right side of the y-axis, it looks like on the left side of the axis. And it says from 0 to 4, the area is 3. 0 to 4, the area is 3, plus 3. Since it's an even, this side has to be plus 3 by -4. It says from -4 to 6, there's a total of 8. 3 plus 3 is 6, so there must be 2 more over here to make a total of 8, which means on this side there's 2, also plus, because they match left and right when it's even. So how much was there between 0 and 6? 0 and 6, 5. Between 4 and -6, I'm going backwards, so all the signs of the areas change. So that's -3, -3, -2, -8. From -6 to 6, if this was an odd, that would be 0. But this is even, so we've got 2 plus 3, 6, plus 2 plus 3, another 6, that's 12. The temptation is to try to integrate this. Please don't, because we're going to take the derivative. Now, what this is, if this is small f of x, which is the derivative of capital F of x, then when I integrate this, I'm going to get capital F of x that I have to evaluate between 3 and x squared. So I'm going to have x squared minus f of 3. But then I have to take the derivative with respect to x. And the derivative of f goes back to this. So that's sine of t squared, but I'm putting x squared in for the t, so x to the 4th plus 2. But I'm taking the derivative of this, and this has got an x squared inside, so the chain rule says take the derivative of that, which is 2x. And then we're taking the derivative of this, but that's a constant, so that's 0. So there's my answer. Next problem. All right, this is addition, this is subtraction, so this is multiplication. Can't split those separate integrals, but I can make this 3 separate integrals. The integral of 4 over the square root of x dx plus the integral of 5 dx minus the integral of 2 secant squared x dx. And now there is a 4 in everything in here, so I can factor 4 out here. I can't factor the 4 out here because there's not a 4 in all three of them. Now, if these were all 4s, then I could pull out a 4. So the integral, and I'd have 1 over square root of x. Square root is a half power in the denominator, so that's x to the negative 1/2. Plus, the 5 can come out, the integral of dx. The 2 can come out, the integral of secant squared x dx. The integral of this is 4. Adding 1 to negative 1/2 is plus 1/2. And then I have to divide by 1/2, so that's x to the 1/2 over 1/2 plus the integral of 1 dx is x times 5, or the integral of 5 dx is 5x. And the integral of secant squared is tangent x, so minus 2 tangent x plus c. This half becomes a 2, so this is 8 square root of x is another way to write that, and the rest of it the same. This one. Now, this one, I don't do u substitution. If I can split it up and do it by pieces, I'll do it. If I can split this up somehow and make this easier, I would do it instead of doing a u substitution. You guys some of you got too used to doing u substitutions. When I got addition or subtraction in the numerator, I can put the denominator under each, and so this would become the integral of 3x squared over 6x minus cube root of x over 6x. And then I can split that up into the integral of, see, the 3 over 6 is a half, so that would come out. One of the x's cancel, and I just get just x dx. And then I've got minus, and then I've got 1 over 6, so I can pull that out of the integral. The integral, and then I got this cube root of x was x to the 1/3. And the denominator x to the 1, so I take 1 from 1/3 and I get x to the negative 2/3 dx. So the integral of x is x squared over 2 times a half minus 1/6. Adding 1 to negative 2/3 is plus 1/3. So I got x to the 1/3 divided by 1/3. So this becomes x squared over 4 minus the denominators multiply here, and so I get a third of x, which is a third of 6, which is 2. And x to the 1/3 is the cube root of x. On this one, you can do a u substitution for x plus 3, but this factors nicely to x plus 3 and x minus 3. The x plus 3's cancel, so we have the integral of x dx minus the integral of 3 dx, which is x squared over 2 minus 3x plus c. Absolute value. Well, we have to be leery of negative areas, so we want to take a look at what this looks like. X squared minus 4x. You can just graph it on the calculator, or if you factor this, you can get x times x minus 4, which should tell you that this goes through 0 and through plus 4. And it's a parabola, right side up. And if we do the absolute value of it, this area becomes positive. So this is a negative area, and we have to change it to a positive area. So we can integrate the original parabola from 0 to 4 of the x squared minus 4x dx. And that would give us this negative area, and we'd want to make it positive because of the absolute value. So we'll change the sign on that. Plus, from 4 to 5, the area is positive, so that we don't have to change that. So we can integrate from 4 to 5, 4 to 5 of x squared minus 4x x dx. And so we get minus x to the third over 3 minus 2x squared, evaluated from 0 to 4, plus x cubed over 3 minus 2x squared, evaluated from 4 to 5. So we get 4 cubed, which is 4, 16, 64, 256. Is that right? 4 times 4 is 16 squared is 256. 256 over 3 minus 16 times 2 minus 32, and then we got the minus of that, so that's minus and plus. Put 0 in here and we get 0, and minus and minus would be plus 0. And here we get 125 over 3 minus 25 times 2 minus 50. Minus, put 4 in here, and we get 64 over 3. And 4 in there is 8. Oh, 64. I did it to the fourth. 4 times 4 is 16 times 4 is 64. I thought I was doing something strange here. Don't remember that number. So there we go. Sorry about that mistake. So 4 in here is 64 over 3. So I got minus 64 over 3, minus 64 over 3. That's minus 128 over 3, plus 32. 4 squared is 16 times 2 is 32, yes. 16 times 2 is, this is 32 also. Man, 2 mistakes on this one. I was doing pretty well until I got to here. Plus 32 plus another 2 is plus 64. Plus 125 over 3 minus 50. Minus 128 over 3 plus 125 is plus, it's minus 3 over 3, or minus 1, plus 64 minus 50, which is 13. Okay. Last page. Okay. A lot of you let u be just that. But with this constant on it, we can let u be ln of 2x plus the 2, because when we take the derivative of this, the 2 becomes inconsequential. And so we get du equals, the derivative of a log of something is 1 over the something times the derivative of the inside, which is 2, plus the derivative of 2, which is 0, dx. So these 2's will cancel, and I multiply both sides by x, and I get x du equals dx. So this becomes the integral, and since I'm changing to u, put a half in here, and 2 times a half is 1. ln of 1 is 0, plus 2 is 2. And then if I put 2 in there, I get ln 4 plus 2. And I get u for the numerator over the 3x times x du, and the x's cancel. The 1/3 can come out, and so I'll have 1/3. The integral of u du is u squared over 2, and I can plug in the 2 and the ln 4 plus 2, which becomes 1/3 ln of 4 plus 2 squared over 2 minus, put 2 in there, and I get 4 over 2. And that's good enough, or you could simplify that. This would be 1/6 of this, and I can FOIL that out, or I can type this in my calculator and get a decimal approximation, and I get 4/6 here, or this reduces to 2/3. Anyway, and I think the decimal approximation on that one, I had it someplace, I can't remember where. Okay, this one. The mess is that denominator. So I'm going to let u equal 4 tangent x, and the minus 5 is not going to hurt to include it. In fact, it's probably better to do that, because then when I take the derivative, du, the 5 isn't important, and it becomes 4 times the derivative of tangent x, which is secant squared x, dx. So dx is equal to du over 4 secant squared x. Okay, I've changed from x to u, so I can change my limits or change back to x, but let's just change it. Tangent of 0 is 0 times 4 is 0 minus 5 is negative 5. Tangent of pi over 4 is 1. 4 times 1 is 4, minus 5 is negative 1. I have secant squared x over u to the third, which a lot of people missed. Dx is du over 4 secant squared x. Secant squared x's cancel. The 1 over 4 comes out, so I get 1/4 integral from negative 5 to negative 1 of 1 over u to the third du. That's like u to the negative 3. So if I integrate it, add 1 to negative 3, and I get u to the negative 2 divided by negative 2. With the 1/4 out in front, evaluated from negative 5 to negative 1, which becomes, let's see, this u to the negative 2 means it's u squared in the denominator. This is 1/8 negative, and a u squared in the denominator, evaluated from negative 5 to negative 1. So this becomes negative 1/8, because negative 1 squared is 1, minus a minus, which is plus 1 over 8 times 25. which is 200. So we got minus 1/8 plus 1/200. We could get common denominator, whatever, but that's close enough. Last one. dy is equal to all of this. So let's find out y is by integrating and putting the dt on this side and integrating this with respect to t. The integral dy is just y equals the 3 that could come out of this first part, and so it'd be the integral of sine. The integral of sine is negative cosine, so we get negative 3 cosine of 2t plus pi over 2. But if I took the derivative of that, I would have to take times the derivative of a 2, and I get a 2. I don't have a 2, so I have to divide by the 2. You could also get this by doing a u substitution for 2t plus pi over 2. du is 2dt. So we'd replace the dt on this part with a 1 over 2. So that's where that 2 comes from. The integral of e to the negative t is e to the negative e to the t. Negative e to the t integrated is e to the t plus c. And it says when t is 0, y comes out to be 2. So we have 2 equals 2 times 0 is 0 plus pi over 2 is pi over 2. Cosine of pi over 2 is 0 times negative 3/2 is 0. Negative e to the 0 is negative 1 plus c. So if I add 1 to both sides, I get c equals 3. So what does y equal? Y equals negative 3/2 cosine 2t plus pi over 2 minus e to the t plus 3.